All right, welcome everyone to the first lesson, the first day on learning about programming. A lot of you are here for whatever reason, whatever your motivation is. You all are here really for a certain result. And one of the results is to become a software developer, maybe because you want to have more freedom in your life economically, more time for your family. It is still a process. Everything that we're learning is still like a college base. It's still like a course in college. It's a lot of information that is going to be presented to you, and it can overcome sometime or be overwhelming sometime. But keep on practicing, keep on pushing forward, because eventually it's going to make sense. You may struggle, but that's okay, because the more you practice, the more you improve. That means you have to put more time in practicing. I had to do that. It took me years to get here, but I want to help to minimize that path for you so it doesn't take you as long. Hopefully, it only take you a couple of months, a few months, no more than hopefully 6 months that you'll be working in this industry. Hopefully, we can get you. So I don't want to put a timeline on it because everybody is different. Some of you is going to take this curriculum and just be going forward with it, and that's okay. Reach out to me if you are going forward into the chapters to ask me questions so you can get an understanding. That's what I'm here for. That's why I want to help mentor you. So don't hesitate to reach out to me, and it will be inside our Discord channel under JavaScript. So this video, once I get it up to the channel, I'll post the video links inside of our JavaScript um, uh, chat, and then you'll be able to ask questions there as well. And maybe some other students will be able to answer some of the questions you may have. So put your questions there, because somebody else may have an answer just in case I don't respond quickly. So, keep that chat up open, keep your notifications on so y'all can collab with one another. And if you can learn how to explain it, that means you're developing a good, strong understanding of what it is that we're teaching you. So here, excuse me, we have chapter 4, data and variables. So let me go ahead and open that one up. Now I am going to read this, and the reason why I'm going to read it line by line, because what happened is, what I found in my experience when I do it this way, people is able to see more out of the curriculum, because I'm going to stop and emphasize certain things to make sure you get it. When you read it for yourself, you may not truly understand everything yet, and you may gloss over some of the information. And when you get to the exercise, you're like, wait a minute, we didn't even talk about that. Then you may find out we did talk about it in this curriculum, but it was like one word or one sentence. But because I understand that bottleneck, I'm going to elaborate more. So bear with me as I read through this, because you may not need that, but trust me, there are a lot of people that will appreciate this, especially those that have learning challenges like myself, like ADHD and a small case of dyslexia. So that really helps people to really be engaged with the curriculum when I read it. And trust me, I believe you're going to get benefit out of it as well, even if you don't need to do this. But don't just take this curriculum by itself. Learn how to do some research and go a little bit deeper using MDN and W3 Schools, which we do have links to those sites as well. So let's begin. Variables and data types. Programs may be thought of as being made up of two things. Data is one, two, operations that manipulate data. This chapter focuses primarily on the first of these two fundamental components, data. Data can be stored in a program in a variety of ways. The most basic unit of data is a value. Pay attention to this. A value is a specific piece of data. That's what a value is. And we're going to explain more as we go forward with some examples. such as a word or a number. Some examples are 5, 5.2, and hello world. We're going to tell you what types of data these are. This is a number, and this is what we call a string. How do I know it's a string? Because it has quotes around it. Anything that has quotes around it is a string. If it doesn't have a quote around it, it could be a number, it could be a Boolean. And we'll talk about that later on. But right now, the two data types that we're going to talk about right now are number and string types. So each value belongs to a category called data type. We will see many different data types throughout the course. The first two of which are the number and the string types. These are data types. Remember this because you need to understand the verbiage, the terminology. That's a big part of being a developer. If you don't understand the terminology and you just call it, that thingamajig, or you give it some other name, nobody won't be able to understand what you're talking about. So understand the terminology. That's so important for you to recognize this terminology and understand it. So here, numeric values such as 4 and 3.3 are numbers. Sequences of chapters enclosed in quotes. I just broke that down. How I know a string is a string because it's enclosed in quotes, such as hello world, or string so-called because they contain a string of letters. Strings must be enclosed in either single or double quotes. So what does that mean? In JavaScript, you can use a single quote or a double quote. That's in JavaScript, but in Java, you can't. In Java, you use double quote for strings, a single quote for a character. And when we get over to JavaScript down the road, when we go into the JavaScript lessons, I'll break that down later on. But for now, we just focus on JavaScript. JavaScript is a dynamically typed language that can be confusing at first because we're talking about data types. In JavaScript, a variable, which we will go over variables, they can hold any type of data type. They don't have to be declared as a data type. You can give it whatever data type you want to give it. It's dynamic. And that'll make sense later on why that is. So here, a string so-called because they contain a string of letters. That's why we call them strings, because it's a string of letters. That exclamation point is a part of that string. Strings must be enclosed in either single or double quotes. Remember, it has to have an opening quote and a closing quote. If you don't have the closing quote, it's going to give you an error. And we'll go over that later as well. And you can't mix quotes. So what that means is I can't have a single quote for the opening quote and a double quote for the closing quote. That's going to give you an error. That's not allowed. It has to be double quote for the opening, has to be a double quote for the closing if you're going to use that particular type of quote. If you're going to use a single quote, it has to be a single quote for the opening, a closing quote for the open, a single quote for the closing. Now, if you are not sure what data type value falls into, precede the value with a type of. Here's an example. We have the console.log, and I'll go over what a console.log is in a little bit. But here we have this particular type of. This is something that allows you to find out what a type is, a data type is. So remember, I told you a string has quotes. When the compiler, and I'll talk about that later on, think like the compiler. When the compiler sees this type of, it knows that, okay, when I see these quotes, I see an opening quote, and I know that I see a string, and it goes through and it gets everything within the two quotes. And it'll come back and tell me what that type is because I'm using that type of. I don't need to use the type of to print to the console because this is all a console.log is doing. All it's doing is printing to the console. And if I want to know what a number is, what type of 17 is, it's going to tell me that it's a number because here's the console outputs. And then here's the type of for 3.1, 3.14. It's a number. Like I said, this may not make sense now, but the more we go into it and the more you practice this, it is going to make sense. But this is fundamental. Not surprisingly, JavaScript reports that the data type of hello world is a string. That's what we see. That's the output. And I'm going to really emphasize understanding how to identify what an output is by just looking at the input. So all programming is about inputs and outputs. That's what programming is basically about, inputs and outputs. And it says, while the data type for both 17 and 3.14 is a number, note that some JavaScript environments may print type names and strings with single quotes around them as a single quoted string, number, and hello. Remember, if it has a quote around it, it is a string, even if it has a number in it, not the word number, but an actual number. It's a string. So whatever is inside of a quote is a string. It doesn't matter what data type it is. If it's inside those quotes, it's a string. And I will elaborate more on that when we get to some Replit examples. So here we go. Notice that console.log type of hello world prints out string. Pay attention to these keywords that we'll be giving you, because over the course, I'm going to show you how to solve the problems by paying attention to the questions and the information that we give you. You must know those keywords that tell you what you need to do or how you need to write your programs or your algorithms. So here's a string to the console. The type of keyword is not printed. Notice here on the output, I put inside the console, because console.log, all it does, it prints to the console. This is the console down here in black, down here, where you see string and number. But notice it doesn't print out type of, it just tells you string. So the compiler is smart enough to know that's something that doesn't want to be outputted. So it only outputs the information that you're looking for. Now we say here, type of keyword is not printed to the console because the statement type of hello world is an expression. This is another word that you need to understand the meaning of, expressions. And when I get into the examples, I'll show you the difference. Briefly, expressions are code segments that are reduced to a value. We will learn more about expressions soon. Note, type of is a JavaScript entity known as an operator. So this is called an operator. Know what it's called, operator. It is similar to a function in that it carries out some kind of action. All functions and methods are verbs. They're action words. So that's one way to remember what it does. It's an action. So whenever we say actions, that's a verb. Anything that's a verb is an action. So a function that perform actions. Methods perform actions. Though the syntax is different from that of a function, because we haven't gotten into the syntax of a function, notice that using type of does not require parentheses. And I'll go over that later, because you got to identify these and know the difference. But remember, type of is an operator. Remember that. Now, there are data types other than strings and numbers. There are actually 7 primitive data types. And then there are data types that can be mutable. Well, I'll explain the difference between a primitive data type and regular data types coming up, which we will learn about in future chapters. So 4.1.1, more on strings. What about the values like 17? Remember when I was saying that anything inside of a quote, it's a string. So notice the number 17 and 3.2, they look like numbers, but they are in quotation marks like strings. So, excuse me, we're going to run this code to find out. So I want you to see this. So I'm going to click on the replit. Now, when you click on the replit, it's not going to do anything because you're not set up with launch code, but I'm going to show you how to do it, how to create your own replet. Matter of fact, somebody answered me, do you know how to create your own replet? Yeah, have y'all played around with replet? Yeah, because I can't see anybody. Just go ahead and say yes or no.
Yes.
Anybody?
Yes.
I can't see it. Yes. So yeah, we're able. Cool. Cool. So we're gonna fork this. So we're gonna fork it. Cool. So I'm gonna tell you how to fork things later on. But here we go. I'm gonna make this smaller, teach you how to use Replit too. So I'm making this fall, and I have mine stacked on top of each other. If you like that, or if you like this theme, you can change that. I like the dark theme because it's easier on the eyes. But if you want to have your stacked instead of side by side, just come to the hit the settings button, come here to stack, click stack, and then hit the reset layout, and it'll reset it to stack. I like it like this because it gives me more room, especially if you're just working on a laptop, so I can see everything inside the text editor. The top is the text editor. The bottom is the console. That's why you see the word console right there. So I'm gonna make this a little smaller. But now if I run this, now remember, type of is an operator. And so console.log is going to print to this console down here. And I'll break down what console.log does later on. So when I run it, it lets me know string, because think like the compiler. This is your first lesson on thinking like the compiler. When the compiler knows that this is a string because it sees those parentheses. You're going to go over this over and over again. You're only going to retain maybe 10% of what I'm saying. So don't feel bad. You're going to have to practice a lot to really get these concepts down. But it's up to you how bad you want it. If you really want it, it's up to you. You'll put the time in to learn this. So as you can see, it prints out string. But now if I get rid of the quotes, and you definitely want to play around with examples to see what different outputs you're going to get. If I go ahead and do this now, what is the output going to say now? What is type of going to be? What data type is this going to be? Somebody answer. And we've only learned 2 data types so far. What data type is it going to print to the console since I've removed the quotes? Say it again.
Number.
Yeah, what's the data type?
Integer.
There you go. It's going. Yeah. Well, we don't say integer in JavaScript. We do, but that is a number. But in JavaScript, we call them numbers. So I want you to know the difference, because when we get over to Java, they're called integers. So it can be confusing once we do other language paradigm. So when I run this, it tells me it's a number. So that's good. So remember, we've learned 2 data types so far, numbers and strings. Now here's well, we know what the question is because we've already played around with it. What is the data type of the values 17 and 32? By looking at it, what is the value?
String.
There we go. And how do you know it's a string?
Because of the quote.
Because of the quotes. Yes. This is going to be confusing a lot of times till you get your head around it, because when we get into booleans and when we get into defined, undefined and null and symbols and big int, those are primitive data types. And we'll talk about those later, because you need to know what a primitive data type is. And I'll give you the difference so you can know the difference. Now, strings in JavaScript can be enclosed in either single quotes or double quotes. Now, we've already talked about that. Remember when I said earlier, and the cool thing about once you get the replit going, you could copy and paste this stuff into your own replit. So if I go over here to this replit over here, I could just paste this in. And I didn't copy it, so let me copy it. Let me come over here. I don't know why it's not doing it. Sometimes this don't work right. So right click, hit copy. The shortcut, I was trying to use the shortcut, and you know what? I was using the wrong key because I'm on a PC. I have both Macs and PC. I was using the wrong shortcut. The shortcut on the PC is Control C. Control C, you got to highlight it, Control C. And then to paste it in is Control V as in Victor. You see that? Now I don't have to do the shortcut. I could have just right clicked it and click copy and then come over to Replit and did paste it in right there. And it would have pasted it in. Now, what I want to say to you all is this, is that learn shortcuts depending on what type of computer you're on. And the reason why we're using Replit for y'all in the beginning, so that you don't have to set up your environment on your computers. That right there is a challenge, especially if your computer is not optimized correctly. So this way you can do the exercises without doing it on your own computer. All right. All right. So if can y'all mute yourself? Someone that's talking in the background. I want to make sure it's muted. So make sure everybody is muted. I would mute you if I can pull you up, but I can't see everybody right now. So make sure you're muted. So here we go. So now if I run this, what do you think that what's going to happen if I hit the run button? Anybody? Somebody take a shot at it. What's going to happen if I hit the run button? What
it's going to tell you what data type
It's
going to what? It's going to tell me what?
What data type it is.
Yeah, what data type is it? Tell me what is going to be the data type. You only know 2 right now. Which data type is going to get me?
string.
There you go, string. So if I run it, I get a string. Now, remember what I said earlier, because one of the things you have to know and understand is the rules, how the rules work. So if I remember, I said, if you use this, you can use a single or double quotes in JavaScript to represent a string, but it has to be the same. It has to be a single quote for the opening. It has to be a single quote for the closing, just like for the double. I can't mix the two. So if I do this right here, y'all see what I did? I mixed it. I put a single quote with a closing double quote. You notice right here in Replit, it's giving me a squiggly line. It's letting me know there's an error right there. So now when I run this, I get this error. I get a syntax error. That seems scary, right? Syntax error. What a syntax error is a compile time error. The software will not compile if the syntax is not if it's not correct. So it's not correct because I'm mixing the quotes. So that's why I'm getting the syntax error. The program is not going to run. Now there's another error called a runtime error, and we'll talk about that later. But I'm gonna put that back, I'm gonna run it, and now it works. One of the things you want to do is get familiar with these errors, because once you learn what the errors are saying and what they do, and you'll learn how to fix your program. But this is something you have to learn. This is definitely learning the process. It's going to take some time to really get your head around these errors, because those error messages, they're going to help you understand where your code is messed up at and how to fix it. But if you don't understand the error message, it's going to drive you crazy. But what you can always do is you can go ahead and copy whatever the error message is and Google it. And there is going to be an answer on how to fix it. All right. So I'm going to put that back, run it. And so now it's working. So now let's go down. So as we read, double quoted strings can contain single quotes inside of them, as in Bruce. Now this is a different one because I got a single quote in here. And I want y'all to really look at this. So I'm going to read this and then we're going to play around with this for a second. So double quoted strings can contain single quotes inside of them, as in Bruce with apostrophe S, beard. And single quoted strings can have double quotes inside of them. Notice the keyword inside. So the outer quote is a single quote, But inside of that single quote, there's a double quote in here. This is called legal syntax, just like using this single quote over S. And we're going to explain to you why is that, how is that possible? JavaScript does not care whether you use single or double quotes to surround your strings. Once it has parsed the text of your program or command, the way it stores the value is identical in all cases. And the surrounding quotes are not part of the value. Remember when we talked about type of, the operator type of, the compiler knows not to print that to the console. Well, the compiler knows that anything inside of a legal quote is a part of the string. That makes sense? Does that make sense, everybody? Does that make sense to everybody? And we'll see an example in a moment, so I make sure we hit home on that. Then the surrounding it with a single quote gives an unexpected result. So now look at this. You see that right there? Now, this is why I want to I want to put this in as an example. So we're going to put this inside our replit. Let me see if I can copy this. All right, so I'm going to copy this. I'm using Control-C for a PC. If you're on a Mac, it's Command-C. So here, I'm going to paste this in. And first, I want you to pay attention. Now, somebody kind of look at this and kind of see if you could take a stab at it. Would somebody like to take a stab at this? And so I'm gonna call somebody's name. Then how about that? And I don't know if y'all can see this. So I'm going to call, unmute yourself, Wilkins. Unmute yourself. Can you hear me?
Yep.
All right. Take a stab at this. I know it seems like I'm putting you on the spot, but
no,
this is how y'all gonna learn.
So what's happening is I will use the double quotes in the beginning in front of the brew B, and at the end of D, I will use double quotes.
Okay. So what do you think is going to happen if I run this?
It's going to present an error if you run it now.
Really? What do you know? What kind of error?
Syntax error.
Okay. Okay, good. So let's run it. He was right. It's a syntax error. And guess what? It's kind of showing you where the error is. Why? The reason why this is happening now, console.log. I'm gonna go over it deeper and going forward, but console.log, console is an object, log is a method, and methods always have parentheses. Now, I don't know if y'all taking notes, but I will write this down because you're gonna probably need this later on. This dot, we're gonna tell you what this dot means. That dot is called an access modifier. What that means is anything to the left of the dot is an object. Everything to the right of the dot is either a method or property. We haven't touched properties yet, but we just got introduced to a method. Do anybody remember what I said a method and a function is? And I want me to call on some names. I can call some names because I want to make sure y'all getting this. So let me call on Miss Hud. Is it Hud?
You want yes, to unmute yourself? It's actually Rita, but yes.
Do you remember? It's Rita. How you doing, Rita?
I'm well.
Now, let me ask you a question. What did I say a method and a function is? Was you here at the beginning of the call?
No, I was not.
Going over chapter 4?
No, I was not.
Okay, then. Well, then you wouldn't be a good example. All right, so I'll go ahead and answer. Remember, a method and a function are a verb. They're verbs. They're action
Verbs.
words. There we go. So that's right. They're actions. Any of all verbs in our English language is action. So whenever you want to, if you give a verb to something, like we always say that love is a verb. It's an action word, right? And so here, a method is an action. It does an action. And what is that action? It's actually getting access to this console. This console is this right here. This right here, this bottom part right here. This is your console. It says console right there. That's an object. And log, all it's doing is printing whatever is inside of it. It's basically taking an argument. And we'll go over arguments later on. But inside of this particular console.log, because it prints it to the console. Now, console is the object. There are many, if you look up the word, if you Google console object in JavaScript, what is the methods of a console object? It's going to give you a lot of different methods. This is just one of them that we use quite frequently. There's more methods out there that can be used with console, but we're using log because what we want to do is print. So remember that word print. Whenever I say print something or display something, you should always be thinking console.log. And what I want to do is I wanted to print this string, but what's happening is, think like the compiler. It sees an opening parenthesis, which is a single quote, not a parenthesis, a single quote. And it knows that it has to have a closing quote. So when it gets to this second, a single quote, it thinks that it's done. Problem is, this log method has some more stuff behind it, which tells the compiler that's not correct. So that's why it's that you can't, you gotta, if it's going to be a open, if you're going to have to use a single quote inside of your string, you have to use a double quote for opening and closing for that to work. Now, this single quote is a part of the string. It's a part of the string, just like if I was to do plus, if I do this comma, all of that is a part of that string. Anything that's in between the opening and closing quote is one string. It may have multiple characters, but it's considered one string. Now, another thing you cannot do that is not legal, you cannot, in a console.log, I can't put two strings in there like that. So I can't do that. That's illegal. I'm going to get, oh, okay, it did. I'm sorry, because I got that comma in there. If I take that comma out, I think this is going to break. There we go. It's missing. So it won't do this right. This is not legal right here. To add that string, I will have to actually put this inside of an array. And we'll talk about that later on. And now that comma, and this is called concatenation. What I just did when I did this right here, it concatenated the two. We'll talk about concatenation later. All right. So is that making sense? Anybody have any questions before I move forward? No questions? You're running back, so that's working. So now we're going to do more on numbers. When you type a large integer, even though integers, we call it an integer, but in JavaScript, we really call it number because integer is a number, but we only have a data type called number. So that's what I mean when I say we don't call them integers in JavaScript, we call them numbers because that's the data type. So there's, just make sure I'm clear on that. You might be tempted to use commas between groups of these digits as in 42,000. This is not legal integer in JavaScript, but it does mean something else, which is legal. That's why I was saying about that comma. Now, can anybody want to take a stab at this? So let me put this over to the Replit. Let's go over that. Let's see if we could take a stab at this. I'm gonna call on somebody. All right. All right, let me see, who can I call on? I'm going to call on Bishop Anthony. Can you see your screen? Because I know you was calling on your phone. Can you see what I'm typing?
Yes, sir.
Okay. What I want you to do, take a stab at this. What do you think the output is going to be with that comma in there? And I kind of demonstrated it. So let's see if you pick up. What is the output for line 1 and the output for line 2? Because I have 2 different console.logs.
The output for line 1 is going to give you a error code, and the one for line 2 is going to
and why so?
go through correctly. Am I wrong?
Okay, Tip. No, explain. Explain why you think that.
Because
all
of
about being a programmer, you want to understand. Go ahead.
Well, it's too many numbers. It's too many numbers in number 1 for it to be read properly.
Mm-hmm.
So you have to put the comma in there to make it read. I can't explain it no better than that.
All right, so that's your explanation. No,
Yeah.
That's okay. And this is why I want y'all to participate, because now what I want to do is I want to ask somebody else, because this is what we do as developers when we're in our meetings and when we're writing algorithm program, when we have all our work we got to do, we have to we have to give our opinions and our viewpoints. We got to stand on our viewpoints and understand why we believe this should be this way. So we're very opinionated as developers, and we have a pattern because of experience on how we like to do things. So now what I want to do is, this is an argument now. Somebody else do everybody agree with what he's saying? If you don't agree, state your reason why you don't agree.
I don't agree. The first one will come out. The first one will come out to be the whole number of 42,000. And then the second one, because of the comma, it was split it up into 42, then a 0.
All right. And like I said, this is we want to understand the rules and the principles. So now when I run it, it does. It printed out. I could put look at how many numbers I could put in here. Put all those numbers in there. It's going to print them all, because that's all console.log does, is print. The reason why you can't put the comma in there, because remember when I put those 2 strings in there and I put that comma in there, it printed out both of them, right? So what happens is, what the compiler does is, when it sees that comma, it's like a delimiter. It separates. And the reason why it only gives you 1 0 is because it knows this goes back to binary numbers. And I'll talk about binary numbers later on. In binary numbers, we have what we call bits, and it takes 8 bits to make 1 byte. Well, bits are switches. They're just switches. This is how your computer program knows how to read it, because what we're looking at on the screen, that's what we call high-level programming language. That's human readable. You and I can read that, but the computer system cannot. It has to be converted to low-level language, which is in bits and bytes, or byte code. And so that means this has to be converted to binary numbers. Well, in the binary number, these are switches. And to binary number, 0 is off. They're off. It's going to see that first one and be like, okay, these are all off. So I don't need to print all of them. I just need to print 1. But now, if I put the number 1 at the end, it gives me 1. So 0 is off, 1. See what I'm saying? And that's the switch. And that's why it only prints 1. It prints the last number inside of the inside after the comma. So this is why you want to play around with it. And you see what it did that time? It did 42 and it did 64, because it's reading the number. It's reading the binary code here. So that's something we'll talk about later on to get your head around that. But there's no magic happening here. you read in your first chapter, if you read the first chapters where it says computers are dumb, you have to tell them exactly what to do. Now, that doesn't mean that they can't adapt and they can't conform, because you can write programs for it to come up with different scenarios so that it can think. And we call it artificial intelligence, which there's a big market for that as well. But I'm playing around with this code so you can see the different outputs. So yes, it tells us that right there, but it gave us the output too. So I don't know who was that gave us the answer. Did you see the output? That's why you knew it was going to work. Or did you already understood from the example, the rules up here that we kind of talked about?
I saw when I read it, but then I did play around with it in the on the website.
Replit. There you go. That's yes. The thing. That's why we have this Replit, so you guys can play around with the code. That's good practice. Now, well, that not what we expected, of course, all because of the comma. JavaScript chose to treat 42,000 as a pair of values. Key, pair of values. Now, let me go over, because this is what I want to tell you about the values. We haven't got into variables yet, but I'll say that for when we get to the variables. In fact, console.log function can print any number of values as long as you separate them by commas. Notice that the values are separated by spaces when they are displayed. And so when you have the comma, it's going to separate all of these by spaces. Now here's the output. So we console.log all these numbers by putting commas in between all of them. The compiler is smart enough to know that comma is not supposed to be inside of the output. But let me do something here. This is where we go ahead and let's play around with the code. Let's try something here. And I hope y'all see where I'm going with this. And that's not what I wanted. I wanted the whole thing. I did the wrong thing. I want that right there. So let me go back here. Notice something here. Does somebody want to take a stab? What's the difference between these two console.log? Who would like to take a stab at this before I call on somebody? I want to see if somebody want to volunteer.
The first one is just numbers, and then the second one is a mixture of number and string.
Okay. And that's legal, right? So when I print it out, it's going to print out exactly what I typed in there. And like I said, the compiler knows not to print out those commas. So when I print, none of the commas got printed out. All it did was the spaces, right? So, but what if I do want the commas in there? How would I do that? What if I want all the numbers and all those words, in those console.logs, I want to see those commas. Is there a simple way that I can do it? And I'm gonna give you the high level way. There's always multiple ways to do things, but can anyone take a stab at what I can do to add commas?
Would you make it into a string and put quotations around all the numbers?
That's what I was gonna say.
Yep, that's a good one. Yep.
Yeah, that's what I thought.
That's one easier way. Okay. Although I still have a spacing. Yeah. But now also I'm still gonna have a space, right? Because I gotta have those commas to separate everything. But if I wanted those commas to be inside of those numbers, I will have to put strings around the number and the comma, but I still have to add another comma to be able to separate the two. Because how the compiler reads it, because that comma actually has a value. It's a value that is assigned to a binary code. That's how it knows it. And so if I go ahead and put a string right here and I put the comma in there, it's going to print that comma, but I'm still going to have a space. Oh, I got a syntax error. Why do I got a syntax error? Can anybody tell me why? What's happening? I got a syntax error. It kind of gives you an example right here. What stands out? How to fix that? How to get rid of this?
You didn't put a
a comma after the dot thing on the console log.1.
There we go. There we go. It still needs that comma. But look at the syntax. This is kind of confusing a little bit, right? It says syntax error, missing a closing parenthesis after the argument list. You got both of the parentheses. So that's, if you don't understand what's going on, what it's really trying to tell you here, what it's telling you here, the reason why it says it's missing, because I don't have that comma there, the compiler stopped. It stopped because it had nothing to tell it to keep going. It stopped because once it got to the end of that little string right there, and it said, I don't see a comma. All I see now, I see these other items that I don't really know what they are, because the compiler doesn't see those numbers. It sees binary code. And so therefore, it's telling you that it's missing a closing parenthesis. That's why it's giving you that right there inside the argument. But that's not the case. You just need to understand why it's saying that. That's why I want you to understand how this works, as opposed to just memorizing the syntax. So when it sees that opening, the compiler see that opening parenthesis on that console dialog, it knows it's a method, and it knows it should be accompanied by a closing parenthesis. Now, to the naked eye, you see the closing parenthesis, but you're not the computer. The computer doesn't see it. What it does is when it goes through that compiler, it goes through that 42, it sees that comma, and it's expecting something after that comma, and it sees that string, but it doesn't see a comma right here. It's basically telling me it's done. It goes all the way, and it's just like, I don't know what to do next. I'm lost. And so you have to give it the logic it needs for it to read it. So now when I print it, it's there. And you know, I still have that space in between because this comma right here creates a space. But we'll learn later on how to make things do it what we want it to do. But this is just fundamental stuff right now. Anybody have any questions so far? And it's okay to ask questions, get an understanding. And so I'm gonna move on. If you have any questions, just hop right in. So remember not to put commas or spaces in your, go ahead.
Oh, so quickly, what I was just gonna recap was, commas are a part of syntax, is that correct? Unless you put them in quotes.
Correct. Yeah, well, it's a part of the syntax to denote, it's a delimiter. It separates. Okay. The compiler knows that I need to have some separation here, because if I take all those commas out, it's going to stop at 42 and just say I have a syntax error, because it doesn't see the delimiter. It doesn't see that there's supposed to be a space there. So that's why when I didn't have that comma in there, it gave me the syntax error, and it was saying that I was missing a closing parenthesis. I'm not missing the closing parenthesis because you can see it, but the compiler can't see it. And that's why you have to think like the compiler. You got to throw caution to the wind here. You can't go by your understanding and logic when you're writing computers. You have to write the programs the way that the computer can understand it. That makes sense?
Yes.
All right. So I take silence. Okay. So here we go. No matter how big they are, also revisit what we said in chapter How Programs Work. We gave you that chapter. Formal languages are strict. We talk a formal language. We understand that. The notation is concise, and even the smallest changes might mean something quite different from what you intended. How many times have we ever done that? How many times have you been on your text and you text someone? If you text someone with all caps, that lets them know you yelling at them, right? If you don't add a comma in the right place, the statement reads totally different, because it's basically running on and you don't know where to pause, right? And so you could take a lot of stuff out of context from if we don't write it properly, right? And that comes back to understanding the rules and the principles of our language. It's the same way with writing a program language. Always write everything with the rules and principles in mind. Once we get that hard coded into your brain, that whenever you write any program, always be thinking of the rules and the principle. Am I writing it the correct way? Am I using the correct syntax? Am I using open-ended colons and curly braces? All of that stuff. You want to follow the rules and the principles. That's how you want to write, and that's how you want to learn going forward, is that whatever you do, remember the rule and the principle. Am I doing this correctly? That should be the first thing in your mind when you start writing something. Because if you don't do that, what's going to happen is you don't have enough experience to do this like second nature. The more and more you do this, it comes natural after a while. You know what everything is doing. You know what an array is by just looking at it. You know what the output is going to do by just looking at it. You're going to understand how the function works by looking at it. But right now, you don't have the experience. So everything you write, you must make sure it follows the rules and the principles. All right. So now we got some type systems. We're going to go over type systems. Every programming language has a type system, all of them, which is the set of rules that determine how the language deals with data of different types. In particular, how values are divided up into different data types is a characteristic of a type system. In many programming languages, integers and floats are considered to be different data types. For example, in Python, 42 is an int data type, while 42.0 is a float data type. Those are two different data types. Now let's hit the note here. While JavaScript does not distinguish between floats and integers, at times we may wish to do so in our programs. For an example, an inventory tracking program stores items and the number of each number in stock. Since a store cannot have 3.5 shirts in stock, the programmer makes the quantity of each item integer values as opposed to floats. That's why I say in JavaScript, we don't have an integer or float data type or int data type. We just have numbered. So as we go forward, we'll learn how to deal with point values in JavaScript. Now, when discussing the difference between programming languages, the details of type systems are one of the main factors that programmers consider. There are other aspects of type systems beyond just how values are categorized. We will explore these in future lessons. So we got a lot to come up with. Now, let me ask you a question. Let's check your understanding. Here's the question. Which of these is not a data type in JavaScript? Can anybody tell me which one of these, A, B, C, or D? And whoever answers, I want to make sure everybody agrees with them. Who want to answer that?
C. Letter.
C? Okay.
Yes.
Letter. How about it? Is everybody else agree with that? Y'all
Yes.
all agree?
Yes.
Awesome. But which is correct? But can somebody take a little step for extra points? Can you explain to me why letter is not a data type? Because we haven't really gone over all of them yet, but why letter is not a data type? All right, I help y'all out. Because a data type is either going to be, there's a primitive data type, there's 7 primitive data types. The primitive data types that, the reason why there are 7, I'm gonna go over this real quick, and I'm gonna elaborate more in the future. But a primitive data type in JavaScript, there are 7 of them. There's strings, they're booleans, they're numbers, there's undefined, there's null, there's symbol, and then there's big int. And big int was just added maybe a year or 2 ago. So there are 7 of them. Now, this is something I want y'all to write this down. in JavaScript, and I'm going to say this a lot, I'm going to drill this into y'all. In JavaScript, everything is an object. Everything. So an object is a data type. So you're correct to know that, even though we haven't really talked about that yet. But everything in JavaScript is an object. Arrays are object. Then you have string objects. Then you have objects that have objects in them. So there's objects and objects. You got a whole functions of objects. Variable. Everything is an object in JavaScript except, remember this, except the primitive data types. Those 7 primitive data types that I told you are not objects. It can get confusing with the string because I just said string has an object, but I'll explain later on. But the reason why primitive data types do not have, they're not objects is because, one, they're immutable. That means they can't change. You have to give it a different string if you want a string. So if I say Terrence as a string, my name, I can't modify that. I have to, if I want to change the spelling of my name, I have to create a new string. And that'll make sense when we understand variables, but variables are objects. But everything else is, everything in object is an object. Everything in JavaScript is an object except the primitive data type because they're immutable. The second thing is because they don't have methods or properties. And we'll explain later. But write that down because I'm gonna keep drilling that in. I'm gonna ask y'all that about 1,000 times until y'all get it, until y'all can recite that out of memory. You're gonna have nightmares about me asking you what is a primitive data type. What's the difference? What's the difference? So we just finished this first little section, 4.1. Now we're gonna go over to type conversion. Now here we go, 4.2, type conversion. And so here, type curve, sometimes it is necessary to convert values from one type to another. Now, with that sentence right there, without reading further, can anybody maybe explain where we may be going with this? Where we may be going with this type conversion stuff? Based on this sentence right here, sometimes it is necessary to convert values from one type to another. And we haven't got into variables yet. So I would just want y'all to take a little stab at it, because thinking like a developer, we're problem solvers. We think, we're thinkers. You know, in my profession, sometimes we got to take a couple of hours just to think about it. You get paid to think. And so this is, I'm exercising the brain. Your brain is a muscle and it has to be exercised. So we're going through conditioning right now. Would anybody kind of want to think, what are we about to go over? What are we about to accomplish in this part of this chapter? Sometimes it's necessary to convert values from one type to another. So up until this point, you know what a type is. What type of data types have you learned so far? Somebody go ahead and answer that. What data types have you learned so far?
String and number.
There we go. We learned the string and number data type. So if there's a string and a number, why would I want to convert a string to a number? And why would I want to convert a number to a string?
So I would think that if you had an application where you're asking for people to input, maybe for say their instance, their age, but then you're going to take that number and multiply it by something or put run a method against it. That's the reason why you would need to change it from a string to a number.
Hey, that is a good observation. Who was that? Because I can't see nobody. Who just answered that?
Carlina.
Who just gave me that example? Carolina. All right, I'm going to break it down to you. See, you just segue into something that you're going to learn later on. You're hitting, you're going in the right direction. But I'm gonna break it down to you. Yes, if I'm asking you to input your age, now this is where the rules come in at. Every input by default turns everything into a string. Everything, whether it's a number, everything is going to be converted to a number, to a string when you input something. But in my database, wherever I want to store it though, I may want my age, although I'm putting in my age as a number. I'm thinking, because I'm looking at it as I'm inputting, that I'm inputting a number, but that's not what the computer is doing. It converts it to a string, but I want it to be a number. So once I get it input, is now being stored, and we'll talk about that later, but now I need to convert that back to a number. And that's what we're talking about, type conversion. So everything, you just took a great stab at it, which was a great example. Now I'm helping you understand what you just said and make sure we put it all together so you can understand the scope of the full, how things work. So that was a good example. So let's go forward. A common example is when a program receives input from the user as a file. In this situation, numeric data may be passed to the program as a string. Like I was just saying, it's going to be passed to the data as a string. It's going to automatically be defaulted as a string. JavaScript provides a few simple functions. Remember this word, functions. We're not going to go too deep in how functions work yet, but we're introducing it to you now. That will allow us to convert values to different data types. We have two right here. We have the number function and the string function. Now notice, these functions have capital letters, capital for the number, capital for the string. Primitive data type string and number are lowercase. They're different. They're two totally different things. Now, we will attempt to convert the arguments into types, number, and strings. See, notice here, the data type of a number is lowercase. The data type of a string is lowercase, but the function of number is uppercase, and so is string. Respectively, we call these types conversions functions. So we call these conversion types, these are called functions. So here we go. The number function can take a string and turn it into an integer. Let's see this in action. Okay. All right, I'm gonna go ahead and put this over to our little trusty Replit. Now let's go ahead and let's look at this. So when I run this, I'm gonna go ahead and run this because we already seen the output. We know that this function right here, this is how you write the function number. And so let me do it down here so you can see what it looks like. This is the syntax. You've probably seen it in your reading so far, but I'm going to just so you can see, this is the skeleton of the number function. Notice it has some parentheses. Functions and methods only have parentheses. They both have parentheses. Methods are just like functions, so to speak, but methods are created inside of objects, which we'll go deeper later on. But a function is your algorithm. It's a piece of code that you write. So this is code that you didn't write. This is a function you didn't write, but you are able to use it. So this is what we call a built-in function. So number is a built-in function. And what is it doing? Notice here that this number 2, 3, 4, 5 is inside of a string. Now this is where it's going to get confusing. Is because how does it know to convert that over to a number? So here, we notice here in the output down here in the console, we know that this is a number because we know it's red, right? It's red. If I don't do type of right here, so let me do this so you can see what I'm talking about. I'm going to go ahead and so you can compare this. And I'm going to take the string, I'm going to take this out of the number function, right? I'm just going to make it a string, right? So you can see how it's color coordinated. So when I run it, you notice the top one has been converted to the number. The second one is in white, that's a string. This number right here is a inside of the number type of number that's printing back the string. It's printing back the string. It's telling you it's a number, but it's printing in white to let you know that it's in a string, although the type of is a number. And the number 17, number, which I don't need to even put that inside of a number because it's already a number. So if I go down here and I do this, and I take the number function off, this is going to still give me 17. So I didn't have to convert that because it was already a number. Now, do anybody want to take a stab at this? How is it now that number is able to convert this into 23 to a number 2, 3, 4, 5? Now let me give you another example so we can see something here. What I want to do is, so I have the number 17 right there, right? You see that, right? Let me do this. And if I put it in a string and I say, yep, let me spell 17 right. Did I spell 17 right? Okay. Will this be converted to the number 17? Can anybody answer that for me?
I say no.
Okay.
It will. I think it will.
Why? Are you taking a guess at it, or can you explain? You think it will? Okay, so we got two opinions here.
Well, wait.
One says no.
I'm seeing the one in quotations. You're talking about the one in the quotation marks?
Uh-huh.
Oh no.
Yeah, number 5. Yeah, a line 5. Would that be?
A line 5. No, I agree.
Why?
I agree.
Okay, so it won't be converted.
No.
Okay, then he agrees. All right, cool. So now my question is this. Can anybody tell me why that? So I'm gonna put this in parentheses right here. I'm gonna put this in quotes. So notice line 4 is 17, line 5 is 17. Will it convert the string number 17 to a number, right? But will it convert the word 17 to a number? Is that possible? Is that legal?
I said no, but I don't. From what I'm understanding so far.
I'm gonna give you a hint. Good. Y'all both are right. I just want to see, can you tell me why? It may seem complicated, but it's really simple. Why it won't convert 17, the string word 17, to a number?
It doesn't recognize it as a number.
Right, because it's a word.
Yeah, it doesn't recognize it as a number because it's written out as
it's a string.
Yeah, it's a string. Yeah.
There you go.
Mm-hmm.
But now I'm finna help y'all really understand why that is. All right, so we're gonna run this through first so we can see our output. You see that it gives me NaN. That's the output you're going to get, because this number function is looking to convert it to a number, but it printed out NaN. NaN, capital N, lowercase a, capital N, is called not a number. It can only convert numbers. The reason why it sees that string is converted into a number, it goes back to binary code. When the compiler, because remember, the compiler can't see this the way we see it. The reason why it can't convert 17 to a number, because it knows that this number is a function, this number function, and I'm passing in the argument string 17. When it sees that string, the quote is not throwing it off. But what's throwing it off is that first letter, which is the S. The S is assigned a value in binary number. It has a number. It knows that S is not a number. It knows the value of this binary number is S. But when we get over here to 17, what it does is when the compiler, it sees the 1 first, and it knows the value of 1 is 1 in binary number. It knows what the next number is 7. It knows the value of 7
is 1.
numbers. Now, that's right. So it sees numbers. It knows that the value of 1 in 17 is a number. It knows the value of 7 is a number because on the binary chart, it's assigned those values. Remember, your computer cannot see this in English. It all has to be converted. And the reason why it's getting not a number is returning me a response, because when the compiler sees that S, it says, well, on the binary number, it's a lowercase s. That binary value number is probably 110 or something like that. So in binary code, that is written out to 00, because remember those bits, they're switches. It has a sequences of switches. It sees it and it says that's not a number. That S is not a number, because when I look at the binary number for S, it's not assigned to a number. But when it sees that number 1, it sees it. It knows the binary code, because all the compiler sees is the binary code for 1. It sees the binary code for 7. And the compiler is developed and programmed to know that that's a number. Now, when I get into binary numbers, there is base 2, which that's binary numbers. And then there's base 10, which we're all familiar with. We all count in base 10. It's called decimal. It's called, you might not remember that's what it was called, because I don't remember them telling me that's what it was in high school. Whenever I think about decimal, I think about that decimal point. But decimal is really the whole numbers. But we were taught place values. We were taught the 1s, the 10s, the hundreds. We were taught that. Well, we have place values in binary as well, which I will go over later on. But not today, but later on once we understand some more. But we know how to count. And decimal, we know how to count from 0 to 9, because we know decimal numbers is from 0 to 9, because look at your phones. Our phones uses 0 to 9. Look at your keypad. You only got 0 to 9. That's why when the compiler sees that, it don't see the whole number 17. The first thing it sees is that 1. It sees the binary code for 1. So it knows it's 1. And basically it concatenates the 7, which is the binary code for 7, and knows, okay, that's a number. I can convert that because in binary code is giving me the number. That makes sense? Or did that confuse y'all?
Makes sense.
It confused you?
No, it makes sense.
No, it makes sense.
But I do have a question.
All right, cool. Go ahead.
So
hit me with the question.
Could you create a function to translate numbers into, or like if a number was, if you type 17, that it would become, read it as a number?
Say it again.
Could you create a function to translate that string into a number?
Oh, okay, like 17
yes.
To the actual number. No, you won't be able to do that.
Okay.
Because that is assigned, right? Yeah. So it will have to it has to be a number. So you wouldn't be able to write. Now, what you can do, and we're going to do this later on, when we create objects deal with key value pairs. I can assign a key to a number. So for instance, if I wanted the letter A, and it's an ASCII table, it's assigned a number. I think it's 67. Don't quote me on that. I have to look it up. So the value in binary number for the capital letter A, I think it's 67. It's 66 or 67. And so right there, I can create an object and give it a key value pair. And I can make that key a capital letter A. And then I can make the value a number like 66. That's one way I could convert it. You see what I'm saying? So if, like, for the number 17, I will have to make the key 17 and the value the number 17. And that's one way I can do it. But it won't, you wouldn't write a function to just outright change it, convert the word 17. I will have to put it in an object, and then I will have to what we call iterate over that object to find the key and get the value of that key. So that's one way to do it, but that's creating an object though.
So
that makes sense. That way over your head.
So what you like you were saying that the reason, if you didn't give the number like 17, if you didn't give it a value with the letter, it would get thrown off when you write it out, because still when you write out 17, the S is the first thing it's going to read, and that's going to throw the whole thing off, right? Or am I?
And not if I put it in an object. No, you're correct. You're correct in what you're saying. But go ahead.
Yeah, what I'm saying is that the S would throw it off unless I gave the S the value of 17. And then it wouldn't even.
No, I wouldn't want to give it 17.
I'm just saying, if I wanted to read 17, I'd have to create a program that makes the S.
If you want
read out,
you just 17. Give the S a number, a value.
Right. That's what I'm saying. I'd have to give it a number, and then, but it would ignore the rest of the set. It would ignore the rest of the numbers because it's going to stop at the S, right?
Correct. It will stop at the S.
I mean, the rest of the letters. It's going to ignore the rest of the letters.
Stop at the S. Yeah, the rest. Yeah,
right.
It sure would be.
So I mean, then it would read out every letter. Yeah. Yeah, you'd have to give every letter.
Well, it wouldn't even read the other letters. You would. So, but that's why you just give one. So, like I said, I'm going to create an object here, and I'm going to convert. You want to always make sure you name everything. Convert. So I'm gonna name it this, right? It's my naming convention. So I'm gonna create this object here, and we haven't got into objects, so just take this with a grain of salt, so I can explain what I mean. In objects, we have key value pairs. We have a chapter on objects that you're going to come across later on, and so here I have a value. So if I wanted this word 17, if I wanted this to be converted to a number, I will have to create a key called 17, like this, 17. And this is how you create a key. And then I would give it that number. I would give it the number 17, right? So this is how I would create that key. So this is only one object, and everything inside of it would be the value. So this is the key value pair. But so how I would do that, if I wanted to, I would have to give every number a key. So for instance, I have to have one. If I wanted to turn the word one into the number, I would have to do it like that. And then I will have to go all the way down. Let me make sure I'm getting the syntax right on this. I will have to go down to the next one. I don't think I'm doing the syntax. To the next one on the object. And then, so like that's 17. If I want to do 2, I would have to create the key like this and go all the way down. And then I would create a for loop. Now I can create a function. that will go over, I'll just call it go over this object. I'm just call OBJ. And then I have to put my parentheses behind it. And then I have to have a code block. And then what I have to do is I will have to create another variable inside of here, which I would say I create another variable because I will have to hold this. And I'm giving y'all variables because I'm getting really ahead of myself. So if I was to create this to make this function, I will create a for loop that will loop over this object to get me all these keys. First, I will loop over the index to find the index of whatever word that I pass in or whatever I'm trying to convert. And then I have to do a for loop, a for in loop to loop over this object. But really, I just need a for in loop because I just want to loop over this object to get those keys, because that only reads the keys. And then those keys will have a value, which that value will be a number, because I'm putting it in as a number. I'm not putting it in as a string. I'm not putting it in as an array. I'm putting it in as a number.
Isn't that like going to a lot of trouble when you could just put the value of the number?
No, because it won't read it. What you're going to find out in computer programming is not simple. It's not simple as writing. You got to spell it all the way out for the software, for the computer. I have to go through and spell this all the way out to get it to do one thing. So if I create a function, let's say I create a function to iterate over this object to give me all the keys, and then I want to assign it to a letter and give me a value of it, I'm going to write probably 12, 13 lines of code just for me to put one word inside that function. And so
right,
you're going to be writing a lot of code just to make it to do simple things.
That's why I was asking. Is there really a reason why you would want to do that when you could just as easily had put the number there instead of writing a long code to recognize the number? You could have just put the number in, right?
Oh yeah, I was just Oh yeah, you can. But I just want to show an example of let's say if you did have a program where you wanted to do that though. What if you did write a program where you wanted to convert every word to a number? So if you wanted to convert the string 17 to the actual number 17, you may have a program that you may have to write. You wouldn't do it for every single number, but you may have a use case where you might, there's a group of numbers that we want to convert to number. If a user, for instance, in the input, they have an option of putting in 3 numbers, and you want to make sure that they don't type in the word 3. So you want to be able to handle that if they did type in the word 3. You may tell them and send them an error. You have to give me an actual number. That's the easy way to do it. But what if you wanted it to be sophisticated and be like, if they put in the letter 3, the word 3, I want to convert that to the number 3. In order for you to do that, you will have to put that inside of an object. And that's something that we call that you want to handle every different scenario. Is that practical? Not right now. I don't see no use case of doing that. But you may run across one day, and you need to understand, if you do run across a scenario like that, you need to know how to do it.
Thank you.
Make sense?
Oh yeah.
Coolio. All right, so we kind of walked through this. Now here's another example. What happens if we attempt to convert a string to a number and the string doesn't directly represent a number, like this 23 bottles right here? So let's put this in a console. Let's look at that. Can anybody tell me? I'm gonna get rid of all this other stuff. I can do this real quick by doing Control A on a PC and Command A on a Mac to highlight everything. Just in case if you got a lot of code and you want to delete a whole lot of stuff. If you want to delete the whole file, you do a Command A or Control A. And I just want to delete everything that was in there because I didn't want to see it all. I didn't want to go through trying to highlight everything. I just did it really quick. So here we have the console.log, and we're trying to convert 23 bottles, which is a string. Will this, given what we've already done, and you've kind of seen this output, because I still got it up there, what do you think the output for this is going to be?
I believe it. I believe it should read the 23.
I think it won't read anything.
Okay. All right. Anybody else agree with me? Okay. But what will be the output? All right. All right. All right. So let's explain. Both of y'all explain your position, because now we're in the meeting. We're at work and we're about to create this feature. And you have an opinion and the other person opinion when we start sizing the story. And let's say you said that, like you just said, you said, no, this is what's going to happen. You got to explain why that's going to happen the way it's going to happen. So explain your position. Why do you think that it's going to print the 23 first?
Because it recognizes it as a number.
I don't believe that.
I believe it recognizes that. It recognizes 23 as a number.
Okay. Now, who said that you think it's going to print out NAN?
That was Carlina. Sorry. I believe that it's going to.
Why do you think it's going to print out NAN?
It's a number function, and I believe that it's going to read that as a string.
Yeah, and then it's only going to read the 2, and then I think it's going to read the 2, and then it's going to recognize that. That it's written as a string, so I think it's going to just kick it out.
Okay.
Yeah, I agree with Carlene.
That's what I want y'all to do. Think through why. Cool. All right. So, all right, let's do the output, and then I'm going to explain why. All right. You were right. Not a number. And Bishop Anthony, you were hitting on the right point. What the compiler is doing is sees the number 2. It sees the binary code for number 2, and then it sees the binary code for number 3. But when it gets to that B, that knows the binary code for that lowercase b is not assigned a number. And that's why it stops right there. So basically what it did, it read 2 and 3. And really the person who said is going to read the 23 first. If y'all can mute, because it's real loud. I need everybody to mute. It's you see oh no, that's okay. When you see that 23, it did read the 23 first. So you're correct when you said it's going to read the 23. The problem is when it saw that B, it knew it wasn't a number and it stopped. It's a syntax error. Basically, it did. Well, I ain't gonna say it's a syntax error. It's a logic error because it did give us a NAN back, and NAN is giving me a value. But the reason for that is it has to be a legal number in order for it to convert it to a number. It has to be a legal number. So you were hitting on the right point. It does read the 23 first. What now you understand is when it hit that B, that letter B, that's when it realized I don't recognize any more numbers, and it hit a wall. And now the compiler is confused. And because it's confused, because it's inside that number function, because in that number function, there is an else condition. There's a condition. You don't see it, but I could tell you that because when it wasn't true, it printed out an else statement, and that else statement printed out not a number. So, and we'll get into ifs and conditionals later on, but that's correct. That's why it printed out not a number. All right. And so it says it right there. I was trying not to scroll down just in case y'all was looking at my screen, but some of y'all might be actually looking at the actual workbook if you haven't already read it already. So here, This example shows that a string has to be syntactically, we see that word, syntactically legal number for conversions to go as expected. Examples of such strings are 34, negative 2.5. These are strings that can be converted to values, to numbers. If the value cannot be clearly converted to a number, then NaN would be returned. There's a return statement that says NaN inside that number function, which stands for not a number. Note, NaN is a special value in JavaScript that represents that state of not being a number. We will learn more about NaN and other special values in later chapters. The type conversion function string now turns its arguments into a string. Remember that when we print a string, the quotes may be removed. However, if we print the type, we can see that it is definitely a string. All right. So the reason why we know it's a string because it turned to white. Remember, I told you about the color coordination thing, just to kind of let you know, but don't always depend on that. But I'm just, in this particular case, we know that numbers are red in the console and the strings are white. So now we have the string number 17. It converts it to a string. We know it's a string because we know it turned it to the color white. That's one good way to identify it. But we know that it converted it because of this, because it always emits, it keeps the quotes out. It don't add the quotes to it. And then when I hit type of tells me that it's a string, which is in lowercase. So know the difference between an uppercase string and an uppercase number versus a lowercase string and a lowercase number. The uppercase number and string, those are functions. The lowercase number and strings, those are data types. All right, let's check your understanding. Which of the following string results in an NaN when passed to a number? All right, so let's go ahead and say, feel free to try running each of these conversions. You can actually put it in a replet, but can anybody recognize which one is going to give me not a number?
B.
Or which following string results in? Yeah. Which one is going? All right, B. Okay. Okay. Is that the only one?
And C.
You're gonna test this out.
I'm curious about.
You're gonna say, why do you say C?
Because it's
all right.
It's that space, the space in between the two threes.
You picked up on that, huh?
Mm-hmm.
You picked up on that. So let me do this. Let's go ahead. Let's test all of these out. This is why you want to get into that repl. I'm just going to put me a couple of console.logs in here. So I can so I had to type all this in here. All right. So I'm going to go ahead and put each one of these in here. And you could do this to yourself when it asks you to check your understanding. Just run it in a repl, see what the outcome is going to be.
Mm-hmm. Yeah, that is the beauty of coding. You can always just try it out.
That's what I want y'all to do. Practice, practice, practice. Play with this stuff. So let's run them. You were right, because that little space is actually a sign of binary code. It's actually signed a binary code. So when it sees that 3, it sees that space in there and it realizes that, whoa, wait a minute, this is not a number. All right, cool. All right, y'all, we made it through that little part. Anybody have any questions? Anything y'all want me to kind of clear up a little bit? No?
So in that one,
right.
It had 2 of them that wouldn't have that would have came out not a number.
Yep.
Or just that one for C.
Let's go back and look at it. Nope, it's 2. B and
Right.
C.
Right. Okay, that's what I wanted to make
Because you
sure
got
of.
that
Okay.
space.
Yeah. Right.
Yep, there you go.
That
So
broke down the number of, it stopped right
y'all
there
learning
at the space,
something?
right? Amen.
That's it. Exactly. And that's why I kind of introduced this binary number, because you all have to visualize this stuff to be able to understand what the output is. We don't guess. We need to know why things behave the way they behave. And I'm gonna give you a whole bunch of tips, a whole bunch of tricks, and a whole bunch of tools to show you how to see it. Because this code, these programs move so fast, you don't know what it's doing. You can't visualize it. You're just basically trusting the outputs. But if you don't never see it, how it's breaking it down, it's not going to truly make sense to you. Eventually, you don't have to use these tools later on once you get the experience, because you already know what it does. So here, that's what we're doing. We are going to go through step by step. And so that's why it's important for y'all to ask questions and get the understanding. Now, real quick, is this helping y'all? Are y'all still engaged right now? But sometimes you might need to take a little break. Do y'all need to take a break for a little while and then go ahead and pick up on this later on your own? Because there's a lot of information I'm throwing at you. Are y'all brains up for it?
I'm good.
Because I can let y'all go on your own, and y'all can ask me questions in the channel, or we can go to the next one, variables. Y'all want to go to the next one, or do y'all want to stop?
I'd like to read up on.
Yeah, y'all want to read? Y'all let me know. It's up to y'all.
There's so many different ones.
Because I got a passion for this stuff. So I'm taking on the silence. Nobody ain't saying nothing. So I'm taking, y'all want to take a break.
I have one question. I have a question.
Go ahead.
Now, even though, you know, I know the answer a little bit to this, but based on that little discussion you all were having earlier about recognizing the number and then moving on, with that 3 based on, should it not read the 3 first, and then should it be 3 and then not a number? You know, I know that because that's not the case, but like, you know, it seems like it's reading the whole thing.
No, it never made it to the end.
So it read the 3, but then
it never made it to the end.
Okay.
Yeah, and it stopped.
It stopped, but it won't print the 3 because they know, because it already knows. That's what you're saying.
Yeah.
Okay.
Right. But see, now this is a function. Inside this function, there's a conditional. You're going to go over conditionals later on in another chapter.
Right.
Yes. So what is saying in that conditional? If number is equal to whatever the binary number is, possibly, then if that's true, it's going to go ahead and print number. If that's false, it's going to print NaN.
Yeah.
And so all of that is being stored in a variable, and it's returning that variable that is stored in. And so whatever number that you put in there, that's like an input. Or I put it this way, it's an argument, because this is an argument. And later on, we're going to talk about this. This number 3 is this string number 3, that's an argument. In that number function, this is how this number function probably looks. So I'm just from my experience, I've never actually seen how it looks on the inside of it, how it's written, but I know how this works. So what it does, so you have this is called number, and then it's passing in a param, and that param is probably called num. And inside this function, let me put this down, it's going to have what I call a variable that's going to store stuff in. So it's going to create a variable. I'm just going to use var. You'll never use var as a variable name, which let me take that back. Let me not use it because that's a keyword. So I can just use, let me do let outcome. And I'm going to assign this. I'm going to either assign it a number like that, because that means I want to go ahead and go through it and add it to it, or I could make it because I want to convert it. And then what I'm going to do is I'm going to do a for loop. And so this is the anatomy of a for loop. So I'm sure this is what it looks like on the inside. So I'm going to initialize that at 0. And then what I'm going to do, I'm going to go over the num.length, because I want to get whatever is inside that string. I want the length of it, right? And then if that's all true, then I want to update my my for loop, meaning whatever I store inside this variable. This is called a variable too, this I. We'll go over this a lot in depth in conditionals. In for loops when we start looping. Inside that for loop is probably a condition. That condition is like if num is strictly equal to, let's say, num, then that statement is true. I want it to go ahead and console log, or I might even not just console log, because this is going to be inside of a function. I'm just going to hit return, because I'm going to use the return num or outcome. I'm going to return outcome. Or no, matter of fact, I'm just going to return a number. So we're going to call it number. So right now, I'm going to just call that number. So that's what I'm storing in there. So if that's true, it's going to run this block of code right here. But if it's false, and when we get into binary numbers, I'll break down true and false as well to you. Boolean, they're called Boolean. If that's false, I want to return NaN. That's probably how that function looks. I'm not 100% sure because I never seen the function, but I can understand the logic. You know what I'm saying? That makes sense to you? So this is how that logic is going to look. Let me put my syntax right. And so this is how that logic is going to look. I did that wrong too.
So you saying that's the reason, you're saying this is the reason why it'll come up to in a everything that you just printed out would be the reason that it didn't recognize.
Yeah, because what it is, it's going to loop through all of this. And what that loop does, this I is a variable, it's initializing at the 0 index. When we start dealing with these, when we deal with the length property, it's always dealing with the index of something. So it's counting through it. The number is the num that you are going to put into number. This argument, this is why I call this the argument. This is what it is. It is an argument. This is the num right here. This is the parameter. So it's looking for an argument. And so what it does is I'm setting number to be at 0, which I could let this just be num, or I don't even need it in there. It may not even have it in there at all. And so it may not have it in there at all. So this is what it probably will look like. It will probably be like, okay, I'm going to loop. I got this I, which I'm initializing as 0. And we'll tell you how to initialize a variable, which probably is in the next chapter. I is initializing at 0. So it's storing the number 0. So it's starting off at 0 because when we're using the length property, it's dealing with the index. So really this I is 0. And this num is number 33. So, and it's a string, because remember it's a string. So it's getting is 0, which is the index. Is that true? If that's true, if there's an index 0, it'll go ahead and store it in I. So now that that number 3 is stored in this I right here. And then it goes to the next index, but there's nothing else there. It's not another number there. So what it does is it stops. So it doesn't have to update. So number 3 is stored in this I. So now So now that I have the num, I have to get the access to that number. So I'm going to need this. I need to get this bracket I right here, which is called an access modifier as well. So if whatever is in this I, which is this number 3, which is stored in this num variable, if it's strictly equal to num I want to return that it is a number. So I want to, instead of number, I'm going to return, I'm returning the console.log for this one, really. I can return console.log number, or I can just return num, which I'm going to call it num instead of number, because that's what I established it. I want to return num to let me know that this is a number. There's probably some more logic written to this, but this has to be true. Anything in between these parentheses has to be true. If this is true, it'll run this block of code right here. But if that num doesn't have a number in it, like it sees right here. So when I go right here, when I pass in this argument right here, this 33 space 33, what it did, it iterated over the number 3, saw the number 3, it knows that it's a 3 there at index 0, and it stores it in I. When it gets over to that space, it knows that that space is not a number, but it does say it's something there. It is something there, which it gets stored at I. It's a space. So it's storing that space in there. And then it goes again and checks, iterates over it again. It updates to index number 2, which is, this is index 0, which is the 3. Index 1 is that space. Index 2 is that 3. And that's true. So it stores that 3 in there because this is all a string. And then it updates and goes to index 4, where there is no index 3. There is no index 3 because it starts at 0 index. So 0 is 3, 1 is space, 2 is 3, 4, there's nothing there. That's the end of the length. So now it's done. And so now if whatever inside I, if it is the number, and it knows that binary code, so it's probably written some binary code right here. It only needs to recognize 10. It only needs 10 binary numbers, because 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, that's 10 digits. And so it only needs to recognize 10 to be numbers. And so it knows that that space is not a number. So that's why this would be false. And then it'll go ahead and run that else statement. And that's how it'll get that not a number. That's just a high level view. I don't know how the function is actually written, but I understand the logic. That makes sense?
Yep.
Or did I just confuse you anymore?
Very
just
good.
Something, okay, I gotta think about that later on.
Very good.
All right, y'all.
Amazing.
So how y'all feeling? Are y'all feeling like y'all need to go on further on y'all and just ask questions in our channel? So ask questions in the channel, or we can keep going. So it's up to y'all. Because I know this is a lot of stuff to be taken in, and sometimes you're like, I got to take a little break now, because we've been at this for almost 2 hours.
I want to go back. I want to go back and review myself and read up.
All right. So what we do? Do y'all feel the same way? Because we can, y'all can ask questions in the channel. Say, Terrence, can you explain these variables? Then we can do a Zoom. We can hop on Zoom again and be like, hey, let me walk you through it. So sometimes you might want to learn it on your own, and then you might have some questions. Okay, y'all feel good about doing that?
Yeah, that'll work. I posted the assignment in the chat.
All right. Okay, coolio. All right, so I'm gonna stop sharing, and then I am going to stop this so this can stop this recording.